Okay, so here's an example. We're going to practice calculating the angular velocity, and I want to calculate the angular velocity of the seconds hand on a clock. So that's the hand that on the clock that goes around to measure seconds. And some seconds hands on a clock, they kind of go like tick, 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 tick. I want to assume that we have not that kind of seconds hand, but the kind that just moves at a constant rate all the way as it's going around. Okay, so I want you to press pause, think about how you would solve this, try to work through it on your own, and press play when you're ready to go through it with me. So I'm going to use kind of my basic definition. First of all, I'm going to recognize that this is an example of uniform circular motion. Nothing is going faster and faster and faster. It's always going at the same speed. That means I can use this simple equation here where I'm trying to calculate the angular velocity. I'm going to look at how much the angular displacement changes over a certain amount of time and how long does that take. So I do know for one full revolution, I know how long that takes, and for one full revolution, I know how many radians that's going to represent a change in my angular position. I know exactly what that'll be. So we're going to consider one full revolution. The seconds hand is going to go through 2 pi radians during that time. And it's going to take 60 seconds because the second hand, it goes around once every minute. So it's 2 pi radians, it takes 60 seconds to go around, so I can calculate that this is the rate 0.105 radians per second. Now technically I should make this negative because that the seconds hand is going clockwise, and clockwise is the negative direction, so I should add a negative there. Let's go through another example. So in this problem, I'm telling you what the angular velocity of the minutes hand is. And I want to know what is the angular displacement of the minutes hand after 20 seconds. So press pause, take some time to work through this, and we'll see if we can get an answer. Okay, so again, I'm going to assume that this is uniform circular motion because I'm going to assume that this is the angular velocity of the minutes hand and that it's constant, it's not changing. So I can use my simple equation here where I can calculate my angular displacement. That's what they're asking me about based on my angular velocity and the fact that we're watching it go for 20 seconds. So here I can just plug in those values and I can solve for my angular displacement. Now these values, I don't expect you to look at this and be like, oh yes, that makes sense. 0.035 radians in the negative direction. Sure, that makes perfect sense. We're not very comfortable with units of radians. So for these types of problems, you're not going to be able to look at this and just be like, why, yes, of course. So we're just, we have to deal with what we have, though. These are the units that we're using. It might not make sense, but I still want you to be able to use these equations correctly.